All right, let's get right into it. The AI gold rush is on, and you see it everywhere. Companies are pouring absolute fortunes into building these massive, power-hungry data centers. But what if all that glitters isn't gold? What if it's fool's gold? Today, we're going to dive into a really provocative analysis from computer security expert Dr. Nicholas Weaver, who basically argues this entire boom might just be a giant house of cards.
And the numbers, they're just staggering. We are talking about a projected investment in AI data centers that's expected to hit $1 trillion. That is a tidal wave of cash, and it's all betting on one single version of the future. A future where AI happens in these enormous, centralized buildings that suck down gigawatts of power.
And yeah, that brings us to the big question, right? What if that fundamental premise is just wrong? What if the tech itself and where it's headed is about to make these colossal investments totally obsolete before the concrete is even dry? It's a really bold claim, so let's break down exactly how this argument works.
To really get our heads around this trillion-dollar problem, you've got to start with AI's fundamental flaws. It all comes down to understanding what this technology actually is and what it isn't.
I love this definition from Dr. Weaver because it cuts right through the hype. Machine learning, at its core, is a tool for finding patterns. That's it. And the most important part of this whole sentence is the end, where it's okay to be wrong. See, any ML system has a real, non-trivial chance of messing up. That makes it super powerful for some things, but, dangerously wrong for others, where you absolutely have to be correct.
So Weaver gives us this really blunt guide for navigating all the buzzwords. He says if you hear machine learning, that's probably talking about something that actually works. If you hear AI, well, that's mostly marketing, so be skeptical. And if someone starts talking about AGI, artificial general intelligence, he says that's pure fantasy. This isn't just him being cynical. It's a really useful way to separate what's real from what's just a sales pitch.
And now we get to the heart of it all. Large language models, or LLMs. Weaver uses a very specific philosophical term for them: a bullshit machine. Now, this isn't just a throwaway insult. It means the system's only goal is to create text that sounds plausible based on patterns it saw online. It has zero concept of true or false. It's just compressing and remixing the internet.
And this distinction is so critical in the real world. Think about it. For something like coding autocomplete, a bullshit machine is awesome. It's a fantastic helper. If it gets something wrong, the programmer just fixes it. No big deal. But trying to use that same tech for, say, medical advice or legal opinions, where being wrong could have huge consequences, that's where you see the real danger.
Okay, so let's get to the second major piece of this puzzle. While we're busy building these absolutely gigantic data centers, there's this quiet revolution happening in efficiency that's making powerful AI smaller, cheaper, and way more accessible than ever before.
The secret sauce here? It's all in the math. You see, for something like scientific modeling, think designing a nuclear weapon, you need extreme, crazy precision. We're talking 64-bit floating point numbers. But it turns out for machine learning, good enough is, well, it's pretty much perfect. By dropping way down to 16-bit, 8-bit, or even 4-bit math, you can do vastly more calculations for the same cost and energy. And the best part? You barely lose any accuracy in the final result. This is a total game changer. And you can see this exact trend playing out perfectly in a device you probably use every single day. Go back a decade. When you talked to Siri, your voice got packaged up and shot over to a massive Apple data center to be processed. It was kind of slow, and you had to have an internet connection.
But today, because of that math revolution, your iPhone has its own specialized chip, a neural processing unit, that's powerful enough to handle a ton of those requests right there on the device. You can set a timer in airplane mode now. The work that used to need a whole data center is now literally happening in the palm of your hand. The AI is moving from the cloud right to the edge.
So what does all this mean for the business model of these gigawatt data centers? How does this shrinking AI threaten $1 trillion of investment?
Well, the current model for the big players like OpenAI is that extreme cost is actually a feature, not a bug. The insane expense of training a model and building the data centers to run it, that creates a moat. It's a barrier to entry that keeps competitors out. Their whole advantage is being too expensive for anyone else to even try to copy.
But what happens when new, super efficient competitors pop up who don't even need that moat? What if they can get you similar or maybe even better results for just a tiny fraction of the cost?
The numbers really tell a shocking story here. Now, the exact figures are kept secret, but the estimates for training a big model at OpenAI run into the hundreds of millions, maybe even billions.
Meanwhile, a competitor like DeepSeek claims they built their model for as little as 5 million books. And look, even if they're off by a factor of 10, that is still orders of magnitude cheaper.
And this is where it all comes together. That state-of-the-art model from DeepSeek, it doesn't need a gigawatt data center. Apparently, you can run it on a small cluster of just 6 Mac studios. A business can then take that model, fine-tune it for their own needs, and run it on a single machine sitting in their office. All of a sudden, the need to pay those massive monthly cloud bills, it just goes away.
So here's the bottom line. Training these models might still take some serious horsepower for a while, but the day-to-day use of the models, what the industry calls inference, that's rapidly moving away from the cloud and onto local devices. And that inference market, that's the steady long-term moneymaker for data centers. And it's starting to dry up.
Which, leads us to the final, unavoidable question. If the need for these huge, centralized AI factories is getting eaten away by more efficient models and powerful local computers, what happens to that trillion-dollar investment when the market finally wakes up and realizes the business model is broken?
According to Dr. Weaver, the answer is stark. It's simple. It's 2 words. Empty buildings. Just specialized structures, built for a type of computing that's already becoming obsolete, leaving behind nothing more than monuments to a misjudged tech future. Now that is a provocative thought to end on.